Hi students, welcome back. Today we are going to learn the second lesson, Shapes and Angles from Math Magic. Hope you all have played with matchsticks or small sticks or some building blocks. You can make a lot of shapes with those items, right? So here two girls are there, they are twin sisters and they are making some shapes. Do you know what is closed shape and open shape? This is lesson number 2, shapes and angles. So here we have two girls. They are playing with the matchsticks. You also might have played with matchsticks, building blocks, or some other kind of a stuff, fun stuff, right? Shapes. Suppose if I draw a line, can you tell whether it is an open shape or closed shape? You cannot say because line is drawn between 2 points. This is one point and this is another point. Say if I draw V, can you tell whether it's open shape or closed shape? It seems to be an open shape as the upper side is kept open. It's an open shape. So how about drawing another line like this? What do you see now? It's a triangle. And can you tell me whether it's open shape or closed shape? It's a closed shape, right? You look at your windows. There are some rectangle, some square shape, something like this. And they are definitely closed if you look at the surface. Like here Rohini made this shape out of matchsticks. Can you tell whether this is open or closed? This is closed. You see end to end are touching. And can you tell what is this object as well? Shape of this object? It is a hexagon. You see how many sides are there? 1, 2, 3, 4, 5, 6. 6 sides. Six-sided shape is called hexagon. Right? So this is a closed shape. And we have sides. Suppose if you look at this line, how many sides are there? You can say left and right, 2 sides. Right? When it is a triangle, in fact, for the open shape, we cannot tell the sides, but we can interpret. So when you look at this triangle, can you tell how many sides are there? 1, 2, 3, right? 3 sides. Rectangle shape like this is having a 4 sides, right? And this hexagon has 6 sides. And Mohini made another shape. Look at the shape. That is again with 6 matchsticks. Can you name this? Not sure, but it looks like a hut, right? Can you tell whether this is an open shape or closed shape? This is a closed shape. You see all the sticks are touching end to end, right? How many sides are there? It's again made with 6 matchsticks. So this is having 6 sides. There is another shape that is made. This is again made with 6 matchsticks. This is looking like a Damaru Dolak and it's again a closed shape. Okay, we have seen the shapes above. And do you know what an angle means? The shapes we have just seen. Let us know about the angles. Angles, as per the dictionary, it is the space between two intersecting lines or surfaces at or close to the point where they meet. So this is a one line that's drawn from 0 to A, 0 to B, and this intersection. This is called angle, and this is measured in degrees. So if we draw a line, so no angles associated with this, and this is not intersecting with any other line, right? If I draw another line like this, then two lines are intersecting and this space, this measure, this angle. So this is not intersecting with any other lines. So practically we cannot say any angles are formed here. So let us draw another line. And this line is intersecting the first one. So here we see the angles are formed. Space between these intersecting lines, and this is called angle. And this is measured in degrees. A dot or the round complete will have 360 degrees. So this will be a portion of that. This angle appears to be 1/4 of these 360 degrees. Okay, degrees are measured like this small zero above the number. Okay, and we have, let us draw a triangle. This is a triangle. This is a closed shape, and this is some angle. And if you measure, if you see, there's an angle outside as well, not just inside, right? This outside angle and inside angle put together, the total is going to be 360 degrees. Here these appear to be equal angle triangles, and we can make like this and like this. You see the angle, this angle is varying. Suppose in this triangle, can you tell this is a triangle, and let us draw a rectangle, a square. This is a square, and you have how many sides? Four sides. 1, 2, 3, 4. These two lines are intersecting. This is a horizontal line and this is a vertical line. These two are intersecting. And this forms an angle that is called right angle. Right means it's a 90 degree. This is 90 degrees. And this is also 90 degrees. 90, 90, 90. Four 90s are how much? Can you tell? It is 360. The angles inside a square all sum up to 360 degrees. Any four-sided shape, the angles inside will sum up to 360 degrees. Suppose it can be, let us draw another four-sided shape. This is called parallelogram. It has four sides and it has four angles as well. And all these four angles will sum up to 360 degrees. We'll come to that in later sections. In triangle has a property that the three angles, we have how many angles here? 1, 2, 3. Three angles sum up to 180 degrees. This is 360 degrees, four-sided. Any four-sided. It can be square, it can be parallelogram, it can be rectangle. So four-sided I call it. Four-sided shape, closed shape. Some of the angles, inside angles will make it 360 degrees. Angles, inside angles will sum up to 360 degrees. Right? In your home, check your room. So all the corners mostly are 100%. They are at 90 degrees. This is 90 degrees. Walls joining the roof or floor joining the walls, all. There is a symmetry you can watch, observe. The vertical, the sides are going to be, you can watch all the angles. This angle, inside angle of this triangle is a small angle, and you can say these two are big angles. And in this, if I stretch it like this, these are small angles, and this is, the top one is a bigger angle, right? See, when we are changing the shape, when we are changing the angles of intersection, the shape of this picture is changing, right? Look at this triangle. So here this is a small angle and this is a big angle. Forget about the degrees or the measures, but big small comparison we are making it here. So here the green ones are the biggest angle. Okay, and the other three angles we have are smaller than these two angles. By the way, this is a five-sided picture, five-sided shape, and five-sided picture shape is called pentagon. You might have heard about the pentagon in some context. I'll give a clue, you find out. That is related to United States of America, USA. The next question, let us see. Can you say, are the angles marked with yellow equal? So look at the below pictures. This is five-sided shape and the pentagon. This is also five-sided shape, that is pentagon. This is having eight sides. Do you know what an eight-sided shape is called? It's octagon. Octagon. Octa means eight, and this is eight-sided shape. And let us see what is this. This is octagon again. Okay. So if you take these two pentagons, all the angles inside a pentagon, this is a regular pentagon, means with all equal sides and equally positioned. So definitely this yellow here and this yellow here are equal angles. And the green, the angle here at the top of the pentagon, the top angle in this pentagon and in this pentagon are equal. These two are octagons, one bigger and another smaller. All are made with equal sides and equally placed, equally aligned, angled, you can say. In that case, the angles inside are going to be equal. So this blue color angle, in fact, all the angles inside are equal. There are how many angles? Eight sides, so you will have eight angles. And this angle, the blue here on the left and the blue here on the right small octagon, definitely will be equal, right? So here we are knowing about the shapes and the angles. So identify the shapes. This one is having a six sides. So these two are hexagons. And at the bottom, the pictures here are regular and they are made with equal sides. What we can compare when two things are there, similar things, then we can compare, right? We cannot compare hexagon with octagon and hexagon with pentagon. So we have two pentagons here. Let us check these. So in this pentagon, this angle is marked with a red. Can you spot the similar angle, same angle in the above pentagon? That is going to be here on the top, right? You have to mark this in the red and this yellow. The yellow will match the angle here, the bottom left, for these two pictures. Now let us check this hexagon, small hexagon and big hexagon. So this green, can you spot what angle is going to be representing this in the left hexagon? So definitely the here this is going to, we can mark here with the green. So they are going to be similar. And same here, it's easy to spot in this octagon. So this one will be equal to this one. You can mark it here. So what is shown here is a square. Suppose they're all equal, right? If the matchsticks are equal, then we cannot make any other shape with this. right? So let us say we have a shape. This is a diamond shape and it has four sides. So we'll change the angles. Right now all the angles are equal inside angles. Now I'll compress like this. I'll change the angles. This is a wide angle, bigger angle. This is a smaller angle. This is a different shape and this is still a different shape, right? Like this, you can play with the matchsticks. Hope you have unequal length matchsticks with you. See, you can play with the matchsticks by creating more shapes. So I have a pentagon here. This is a pentagon. So how many sides it has? It has five sides. So right now it's a right pentagon, means with all equal sides and equal angles inside. Let me change the angles. Here you see two wide angles, two bigger angles, and the one smaller angle here, and this is also some wide angle it seems, but these two are equal and the opposite angles are equal in this picture. Okay, like this you can compress, you can make different angles. Like this is looking like a crown, and with eight matchsticks. This is an octagon, and you can play with these sticks by changing the angles. And seven matchsticks. Septagon. We have seven sticks, and take different number of sticks and play. Here we have got decagon, so 10 matchsticks. You can take some building blocks or small sticks also to make. Caution, matchsticks. Don't play with the matchsticks. They are fire hazard. I advise you to use some sticks. You will have some pencils of equal size or some toothpicks also. Not that dangerous, but you can use toothpicks or earbuds to, to play with the shapes. Here is a matchstick puzzle. Make 8 triangles using 6 matchsticks. Try. This looks like a fish, and you have how many matchsticks here? 1, 2, 3, 4, 5, 6, 7, 8. 8 matchsticks, and they formed a fish, right? Now, here is the task. Now, pick any 3 matchsticks and put them in such a way that the fish now starts swimming in the opposite direction. Try that. And here we have how many matchsticks? 3 plus 3, 6 plus 4, 10 matchsticks here. This is the shape is some glasses, and here the task is pick up 5 matchsticks and put them in such a way that you get the shape of a house. Yeah, the center portion is already looking like a house, and you have to play with 5 matchsticks to make it look like a house. Okay, play with your friends to make maximum number of shapes out of some say 5 matchsticks, 6, 7, like that. Friends, play like this. You take some 10 sticks and make maximum number of shapes that are possible. And who makes most is the winner. This angle and this angle, I want to know whether they are equal. So there is an angle tester. In the geometry box, you have a divider. With that, you can check the angles. Right? Open it such a way and put it on one side and take it to the other side and measure it. If it's more or less equal, that you will find out yourself. Of course, you can make your own divider. Try this. Cut 2 strips from the cardboard sheet. Fix them with a drawing pin. Done. You have this divider with you. You can move these strips easily and you can measure the angles. Right? This is a square and the corners are intersecting at right angle. Right means it's a 90 degrees. You see, they are L-shaped angles here. So L-shaped angles and like this intersections or inside angles are going to be 90 degrees. And outside, do you know there is an angle outside? The outside angle is going to be how much? The inside we said it's going to be 90, right? And outside it will be 360 minus 90, as the whole angle has to be 360 degrees, right? In a clock, if you see, the clock is round, right? In clock, how many degrees each hand has to traverse? It is 360 degrees. It's a minute or hour or second. From midnight to morning 6, it is 6 hours, and that is going to be 180 degrees this side, 180 degrees this side. So morning 6 to afternoon 12, it's going to be 180 again. So 180 plus 180 is going to be 360 degrees. We have 12 hours in a clock, right? The clock is 360 degrees round. Each hour, when our hand moves by 1, each hour will traverse how many degrees? 360 divided by 12. That is going to be 30 degrees. So 3 hours, if it traverses, it is going to be 3 into 3 is 90 degrees. So that is a right angle again. The clock, you can make a clock. It's easy to make. You draw the pictures, lines and all. This intersecting two lines we have here, these two are intersecting at 90 degrees. And you see here we have 12 and here we have 3, 6 at the bottom. The left you have 9 and 0 or 12 again. So the whole clock is 360 degrees and each hour is 30 degrees. And you can play with the shapes around you. It can be a window corner, it can be a room corner, or your table corners as well. Right angle. What is right angle? This is right angle. This line, the angle between this 12 and 3, this is 90 degrees. They are perfectly right, perfectly perpendicular lines. So 90 degrees. Okay, let us see if it's a right angle, more than a right angle, or less than a right angle. The scissors, if it's a small open, it is less than, you can say, suppose 12 to 1. Okay, this is between 12 and 3. So 12 and 3 is 90 degrees, and this is less than that, right? Less than 90. It may be 30. If it's a 1 hour, around 1 hour, it's a 30 degrees, right? Like this. And if you put an elbow like this is a right angle or more or less. It appears to be right angle. You tick here, right? This is a kite of square shape, right? Then this angle is going to be, in fact, all the angles are right angles inside of this square. And you have some tool here. Can you tell this angle is right angle? I think it appears right angle. And you have stop sign here, that is of the shape hexagon. And the inside angle here, the white color angle, definitely is not right angle and is more than right angle. So you have to mark here, right? Practice like this with more shapes around you. When you go to any museum, you see our ancestors have made the tools resembling to some shapes. This is some tribal picture, and you have a task here. Right angles mark with black color. Do you see right angles anywhere? So here we see some triangles. They are less than right angle, less than 90 degrees. And here we see some rectangles. Yeah, they are right angles here. Inside angles are 90 degrees around approximate. And don't worry about the perfectness. Just want you to identify the angles and the shapes. Here you see this dress, yellow color dress of that maybe some Supreme. Seems to be having some right angles here, like this. You mark them black. Angles, angles which are more than right angle with the green, angles which are less than right angle with the blue. Okay, have this fun. So we have some shapes here. Quickly, can you tell whether this crocodile mouth opening is less than a right angle? Yes, it is. Here we have L here. Is this right angle? Yes, it is. This one? Yes, it is. And this one is more than a right angle, right? More than 90 degrees, maybe around 120. You can go to the clock for any reference. You see here this line, this is 90 and this may be around 30. So 90 plus 30 is 120, approximate. And this one looks like a V. In the clock, if you see 11:05 looks like this. This is a V shape and definitely less than 90. And this is also less than 90 degrees. So they're not right angle. So another activity. Take a square paper, take a square sheet of paper, fold it half and fold it again. You know how to make a boat, right? So like that, you fold it again, fold it from the top corner like this, and you will see some angles. And you will see some angles and play with them. Try marking, try asking questions with your friends. You know, our body is so symmetric. Here we have some pictures, and this guy is sitting, this guy is sleeping, maybe. This guy is looking like some dance, running, and so doing some athletics. Okay, you can measure the angles at the intersections of each one. The nature also has symmetry. You see, all the trees grow vertically, perpendicular to the ground. So they are at 90 degrees or at right angle to the ground. And the branches, sometimes they are at right angle, sometimes they spread at right angle, and sometimes with the different angles. Watch the trees around. Even the leaves also. If you look at the structure of a leaf, you will know that they are having some symmetry, some angles embedded in that structure. Birds. So these birds, their beaks, you see, math magic. We are studying math magic because maths is magic and fun. Everything is based on mathematics, calculation. Life is a calculation, you know. You see these birds, beaks, they're all having a definite structure, definite shape, definite angle, right? With the building blocks or the matchsticks you have, you can form the names and check for the angles. And with the sticks and building blocks you can form the names. You can count the number of angles, right angles you may have in each of your name, right? So this is a small activity. Slide. You play with the slide, right? The slide will be mostly at 60 degrees. Like this book is leaning against the stack of other books, almost at this angle, and you will slide faster. What happens? So let us see. So usually the slope of the slide will be like this, and you will slide. You have the experience. What if I make it like this? You see, you climb like this and you slide. You will slide faster or slower? Definitely it's going to be slower, right? There are many other parameters, many other mathematics, physics involved here. So I'll give a clue, that is gravity and the friction, which you will come to know sooner. These are the slides which you experienced. This is having a more angle, inside angle, and this is having a small angle. So you can see, you can tell the difference in which slide you will slide faster and you will slide slower on which one. It's always safe to slide slowly. So that's why I suggest this boy to opt this right slide. Okay, another caution advice while using the matchsticks, remove the powder or the heads of the matchstick. So that is for the safety. Never play with the fire. It's a word of caution, and whenever you are making projects with matchsticks, playing with the matchsticks, remove the heads so that there will not be any fire hazard, fire risk. Here is an activity changing the shapes you can do. So take some rubber tube. You may find some rubber tube or some straw in your home and take some matchsticks with heads removed. Cut the tube into small pieces. Insert two sticks in a tube end to end. So that is going to make a stick like this, single stick, but that's flexible. You can bend it. Like you do this experiment, like these two sticks are taken, you can add another one and join by the tubes, and that's flexible. Like this, you can make some forms. Wow, all these shapes you can make. Try it, experiment it. And by touching each side, pressing or pulling, you can change the shape of this object and you have the fun. Shapes and towers. So when you go outside, you might have seen the bridges, you might have seen the big buildings and the malls. They all look like made up with some shapes. Means whatever the material used is is fabricated in some shapes to give the strength, and to meet the purpose. On the right side, it appears to be a railway bridge, and you see some triangles. This material, these iron beams, are put in the triangle shape for added strength. And here in this building, you see all the beams, all the pipes, angles are positioned or fixed in a certain form. They are forming triangles for added strength. And this tower, electrical tower, when you go outside, watch for the towers. Even these mobile towers also will look like this. And the structure, they make it this way. They mostly use the triangles. As triangle is the most stable and adds strength to that structure. See, like this, if this is a triangle and if I fix these two into the ground, then this point is also fixed. It added strength. For additionally, if you want more strength, you can add another beam here so that this doesn't move and gives a strength. You check these structures, and what if they make the structure with some square shaped objects? Means they make this structure with the squares. What will happen? They may collapse. You think, why don't they use the squares or other shapes other than the rectangles to make these towers or the structures or the buildings? You will know the reason which one is going to give more strength. So, clocks, time in the clock, all represent some time. Time in the clocks represent angles, and you can watch, say 9 o'clock. So, what is the angle between this small hand and the bigger hand, hour hand and minute hand? It is 90 degrees. You can say it easily, right? So, there are many times the clock makes right angles, less angles, and more than right angles. Here we have some clocks. You're in the fifth standard and hope you all know how to look at the time. These are all analog clocks. We have digital clocks that are coming up. Mobiles show you the digital clocks, right? These are analog clocks. Hope you will have one at home, right? You can read the time from those clocks. So this is 7:25. This is 8:15. Maybe AM, maybe PM. This is 9:10. This is 9:25, 10, 10 o'clock. So observe for the right angles and mark them. Okay, at what times and in which formation the minutes hand and hour hand makes are at right angles. Suppose what happens if all the three hands, hour hand, minute hand, and second hand, are in a single line, that is going to be 0 degree or 360 degree. Like if I draw a line, this dot, it can be 0 degrees or it can be 360 degrees, right? So if second all the three hands in a clock are aligned in a single line, say that is 0 degrees. And when all the hands, when the hour hand travels like this and comes back, it's making 360 degrees, right? Okay, so a second's hand will make 360 degrees in 1 minute. Minute hand makes 360 degrees in 1 hour, and hour hand makes 360 degrees in 12 hours. Watch your clock and check yourself. These are the answers to the match puzzles we have seen earlier. So, you know what is this? You might have played. This is a carom board. You can see the shapes here, the broad shape, on the inside some lines are drawn, they are at some shape, and all these shapes are having right angles. They are fixed, they are made with a right angles. And some circles here, that's also a shape, right? The coins are also having shape. You can tell the shape of the coins, they are circles, right? Circle shaped. So it's all mathematics. If you want to strike the coins here, so this is your striker, you have to play, you have to practice at what angle if I hit, you have to strike at an angle, right? Practice it. You're going to be master at angles after playing caroms. No, unknowingly you are using calculations, angle calculations, while playing caroms. This time, go and play with angles and you will succeed better in getting more coins. Degree. Degree is denoted by a small circle. This is a degree symbol that is appended to the number. You can use a symbol, degree symbol, or you can write degrees as well. This small circle notation is used for denoting degree. Can you make a clock and mark it with degrees? You can call it a degree clock. You cut a circle, fold it into half, fold it again into a quarter, fold it one more time. Right, when you open it, you will have these folding impressions and you mark them with the degrees. And you can, in fact, at the center you can make a hole and put some stripes, hands and minutes, join them together with a pin or so, and you can make a clock look alike, and you can play with these angles. You can test, you can play with your friends. So right angle we said is 90 degrees. Half of right angle is 90 divided by 2, that is 45. Right here 0, 90. So the half is going to be 45. 1/3 of a right angle, that is 90 divided by 3, is going to be 30. Right? 30 degrees is representation of 1 hour by the hour hand in the clock. What is 2 times of right angle? 2 multiplied by 90, that is 180. That is the angle from 0 degree this side. Suppose say this is 3 o'clock and this is 9 o'clock. So when the hand starts moving from here to here, that traverses 180 degrees. Again, if it traverses, then it makes another 180 degrees. 180 plus 180 is 360 degrees. That is a full circle degrees. So this is an aeroplane. This is all mathematics again. You're playing it, you're making it already. So make an aeroplane and check for the angles. Which angle is the best for better flight? So hope you all know about yoga. You wake up in the morning and do this yoga and other aerobics, exercise, walking, running, and you can observe the angles when practicing yoga. Okay? And yourself will know about the angles better. So, what is this angle in this yoga posture and the other postures? If you have a compass box, you will have this D look-alike, D-shaped item that is called protractor, where you can count, you can check all the angles. You will measure the angles of any object. You can draw. You play with this protractor for marking angles, making angles, drawing angles. This is most useful tool in drawing pictures. This is most useful mathematical tool. Thank you children. We'll meet again in another session.